Here we want to evaluate the limit as x approaches infinity of the quotient x squared all over the quantity x plus e to the x. The way we're going to evaluate this is thinking about rules of dominance. So we want to look at the numerator and figure out what type of function dominates it. Well, there's only one function up there, x squared. And what type of function is that? That's a polynomial function. And then we want to take a look at the two terms in the denominator. X, well, that's a polynomial, and e to the x is an exponential. Now, towards positive infinity, which of these two is going to dominate? Well, e to the x is. So exponentials do grow bigger, faster than polynomials. So just looking at these two polynomials really quickly, just doing sort of a very quick sketch. So the function y equals x looks like this, whereas the function y equals e to the x looks like this. So e to the x is sort of shooting up faster towards an infinity versus just y equals x. So it's a very rough graph to show, but exponentials in general always grow bigger faster than polynomials. So just comparing to this specific polynomial y equals x, we can maybe see how e to the x is, getting up to infinity quicker. They're both going to head towards infinity, but this one's going to grow a little bit faster. So on the bottom, we're dominated by an exponential, e to the x. So now we look at the numerator and denominator and think, well, if the bottom is dominated by an exponential, and that grows bigger faster than a polynomial, if the bottom of a fraction is growing bigger faster than the numerator, then overall those quotients are going to be getting smaller. They're going to be getting closer to 0. So I like to think a little bit in extremes here. If the bottom is getting bigger faster, so think of a number really big, like 1,000,000, and then on the top, think about something smaller than that, right? So I'm just going to pick 1. So this overall number is very small, right? 1 over 1,000,000 is very tiny. So this type of quotient is going to be heading towards 0. Here we want to evaluate the limit as x approaches infinity of natural log x plus cosine x all over the square root of x. In the numerator, we have natural log x, so a logarithm, plus cosine x. Now, cosine x, like sine x, oscillates between -1 and 1. So between these two terms, which one dominates? Well, the logarithm does. Natural log of x is heading towards infinity. We know it's getting there slowly, but it's still heading towards infinity as x values are heading towards infinity, whereas cosine is just bouncing back and forth between -1 and 1. So the top is dominated by a logarithm. Now, the denominator is not a polynomial. So polynomials have x to positive integer exponents. So if I rewrite the denominator here, the exponent is not an integer, it's a fraction. So we have x to the 1/2. So this is considered a power function. So as long as the exponent is positive, this is considered a power function. And power functions do grow bigger faster than logarithms. So logarithms just absolutely grow the slowest. So here, the dominating power function in the denominator is growing bigger faster than the logarithm in the numerator. So if the bottom is growing bigger faster, so the bottom is huge, like 1,000,000, and make the top small in your head, like 1. 1 over 1,000,000, that's really small. So this whole thing is going to 0. So all of the problems here as x approaches infinity could be evaluated by thinking about those rules of dominance. So make sure that you take a close look at the comparison of the various types of functions that is provided.